everybody, welcome again. In this tutorial we'll talk about the PIR or passive infrared sensor. We use this sensor to detect any movement or any motion in the surroundings, so we can send signal to the microcontroller to activate something, like activate the light, activate the ventilation fan, or for security purpose or for any applications. Today we will talk about this sensor. We will learn how to connect it to the Arduino, and we will see how to read the signal, and also we will learn how to add more components to it. I'm not sure, maybe we can improve the accuracy, or maybe we can add more functionalities. For example, we can add NTC and LDR. This all and more we will talk about in this tutorial. It's worth to be mentioned here that this module of sensor is the HC-SR501 PIR sensor, and I believe most of the sensors, they are identical, just different models. They all come with 3 pins, which they are a VCC, ground, and the signal output, okay, which is the middle one. So now we will try to supply VCC and ground to the sensor. For sure is a 5-volt tolerance, so supply the 5 volt from the Arduino. We will try to read the output of the sensor, maybe using a multimeter or the oscilloscope to see what type of output this sensor will give us. Here we go. So here is the PIR sensor. I already connected to the Arduino power supply. I'm using Arduino now as a power supply only. So the ground connected to the ground, VCC connected to the 5 volt, and the signal is here. This here was the signal. So now I'm reading the signal using the multimeter, so we can see how it's behave when we move around, and we can check whether it can detect the motion or the movement or no. So now I will connect the Arduino to the computer to power up. Here we go, it's already been powered. Where is the LED? Here we go, and I will power up my meter. So now you can 0. Let me stand still. Here we go, 0. If I move and make any movement, here we go, it detects again. Stand still, go back to 0. If I move my hand around, here we go, it's triggered again. So we can see that the output is just 3.3 volts output. Solid output 3.3 volt. There is no encoded data or something we need to decode it. You just need to read the voltage out from the sensor itself, which is quite straightforward. And also I believe we can use it without the Arduino. We just have like trigger circuit with a MOSFET or transistor, and we feed the signal to the base to activate some alarm or any other things we can do. Yeah, and also there's something I want to mention for you guys, that there are 2 potentiometers here. If you can see, there are 2 potentiometers. The one on the right is to set the delay. Actually, it's not the delay, it's just to set how long you want the data or the output to stay high after it's detecting something. So I can say the pulse duration, the one on the right. The one on the left is the sensitivity, how sensitive, or I can say the range of the sensing of the sensor. Okay, I guess is, if I'm not mistaken, is from 1 meter to 8 meters, 10 meters, something like this. So this is sensitivity. This one is how long you want the pulse to be stay on or stay high, which is, I mean, this one I guess set now to about 3 seconds, should be more than enough. If within a second Arduino can detect this signal, I can do whatever we want to do. Okay, so this is just a rough test. So now we are confident enough to feed this signal to the Arduino, and we will read it and see what we can do with it. So here, guys, just for the demonstration purpose, I have connected a buzzer, okay, to the pin number, if I'm not mistaken, pin number 9. It's a PWM, so we can use it as a siren. And also I have connected the PIR sensor output to pin number 2. So when we move around, or when the PIR sensor detects there's a motion in the surrounding, send the signal pin number 2. The MCU will read the signal from the pin number 2. Then we'll send a siren PWM to the buzzer. So let's go and see how to do or how to write the code for this example. Well, so let's write the code for the PIR with the buzzer. First of all, I will try to implement the buzzer function. So we need let's say hdefine. Let's use hdefine. Buzzer bin. Buzzer bin 9, and we need to define the pin mode. So pin mode of the buzzer pin, set it as out for sure. Yep. Let's see if everything okay. Compiler should be happy. We don't have much of coding. Compiling, and yeah, should be happy. Anyway, yep, done. So here I will declare my function somewhere here. So void siren. Yep. So void siren. What I need to add? Let's add the parameter of the function, which is integer minimum frequency, and then we have max frequency and delay. This delay will help us to set the tone of the siren. Later we will see how it will affect the tone. So this is the step delay. Yep, not only delay. So yeah. So what will be here? We have 4 loops. So for integer frequency equal the minimum frequency. Yep. And the frequency should be less or equal the max. Yep. So frequency, and the frequency is just, we will increase it, let's say by 10. Then we will set the tone. This is a PWM function. So the tone of the buzz bin, tone of the buzzer bin. Yep, buzzer bin. We will send the frequency. Then we will set a delay. Delay following the step delay. Yep. There we go. So this is the, let's say the positive tone or the going up pitch. Now we'll go down. So go down will be, it's exactly opposite. So will be equal to max frequency. And this one should be more or equal to minimum frequency, and the frequency will be -10. Okay, I believe that's it. Let's test it out. So here I will call the function, which is siren. Yep. So now the minimum frequency, let's say 1000, maximum 2K per 1000, and the delay, let's say 5. Okay, let's upload to the Arduino, connect to 11, let's go. If everything good and uploaded to the Arduino, you should hear the siren at the background. There we go. Can you hear it, guys? It's shouting. So now I'll change the delay. Let's say I'll increase it to 10. Let's see what will happen. For sure, it takes long time to go up and down will be longer. You see? Go up and down, up and down. But for me, I like it to be just like one. It's up to you guys. Anyway. Let's see one. Yep, here looks like more rush siren. Okay, let's turn off our siren and continue. So yeah, anyway, this is just for a demonstration, and you can trigger anything else like turn on the light, turn on the fan, but this is just for demo of the safety application. Okay, so we turn off the siren. So now in the while loop, the thing is we need to see if there's any signal coming from the PIR. So let's define the PIR pin. I define. So I have PIR pin. I'll connect to pin number 2, digital pin 2. And again, this one will be input for sure. So this one will be PIR. Yep. So just do this, then will be inputs. Yep. So now, what I will do, I will just monitor or see if and only if there is a digital read. Yep. If I digital read my PIR pin, if it's active high, I mean I got the high reading PIR pin, then what I will do is I will turn on the siren. Yep. That's so, and that's it. Let's see. Done. So now if I move, here we go, I move my hand in front of the sense. And can you notice this sound? If I move my hand, okay, let me turn on the other camera, guys, so you can see what I'm doing now and why there's another sound in the background. Let me turn off this for the time being because it's very noisy, and I turn on the other camera. So now let's reactivate the code to see how it works. So I will upload again. Here we go, it's done. So now if I move my hand, you see, it's triggered. Then we have this tone. Okay, again, I'll move my hand. It's triggered again, and we have the tone in the background. Why is this? If you remember, guys, at the earlier this video, the signal will go low when there is no motion. Okay, so if we trigger it, will go high, then there is a delay about like few seconds, and it will go low again. So that's why we have this continuous tone, because it doesn't execute this anymore. So it will just like maintain the last tone that's been set to, and exit the function means this function doesn't call anymore, but just stuck with one tone. Now again, I'll trigger. So how to keep it continuously trigger unless we reset it? So we need to add what they call while loop. So if while true or while 1, then add this. So now with this code, the function will be called continuously once the PIR sensor being triggered, and this is what we want. Okay, so now it's been uploaded and good. So now you see when I trigger it, it should continuously stay triggered unless I restart it. There we go. See, if we keep it for a longer time, it will be continuously firing the alarm. So now I'll reset it. I reset it actually just by press the reset button. There we go. Then I can trigger again. Boom. Reset. Yep, so that's easy and straightforward how to just keep monitoring the pin and do whatever you want to do when there is a signal coming from the PIR sensor indicating that there is a motion in the surroundings. So whether we can trigger a fan, light, siren for security or any other application. Okay, so for now, we will try to implement an example where we want to trigger a light bulb. So we assume this is a LED light bulb, or we can assume is a relay that connected to a light load, okay, or fluorescent light load. Anyway, I will use just this big fat LED. So what I will do here, I will take out the buzzer. We don't use buzzer anymore here. As in this example, we use the light. So in this buzzer, we will have the plus and minus. So this is the minus, I believe, will be here. And the plus will be here. Yeah. So the plus will be connected to pin number 9. Yeah. So now let's go to the computer and we just modify the code. So this is the code where we left it in the previous example where we run the siren. So now I will take out the siren and I will just use a digital light to drive the LED to the full brightness. So I will use a digital write function, and again digital write to our pin buzzer pin, and I will send 1. There we go. Let's send. Okay, so we have done uploading the new code. So now if I make any movement in front of the PIR sensor, I should see the LED, the red LED triggered as a full brightness. Here we go. See, if I move my hand, the LED I can see is triggered at the full brightness. So with this, we have succeeded to trigger the light or turn on the light if there's any motion in the surroundings. But if you notice something, guys, now we are triggering the light. However, the light is still there. I mean, I still have a light in my room, but when I make any movement in front of the PIR sensor, the light still trigger. You see now, as you can see, it's already bright, but when I make a movement or make a motion, the LED trigger again. That is an example. If there is a sunlight, for example, in the daytime, then the PIR sensor be triggered, then it will send a signal to the MCU, then it will open or trigger the light, although there is a sun, which is not good. So what we can do is we need to add another sensor. We need to add this piece here. This one is the LDR or light dependent resistor. So we can add this to our MCU so it can read the ambient light. Then when it detects there is a light, it will not take any signal from the PIR. Unless it's dark plus PIR, then it will be trigger the light. However, instead of this extra step we add on, we can directly add these LDR. If we disassemble this, the cone or the cover of the PIR sensor, we can see these two holes here. Okay, these two holes is meant for, or two pad is meant to add the LDR like this. Sorry if it's not clear in the camera. So it's meant to add our LDR like this to our sensor to give it the ability of detecting the light. By soldering this LDR at this point, our PIR sensor will be intelligent enough to not give us any signal unless it's dark with the help of the LDR. If they sense there's a light, so the circuit will be disabled, I will not send any signal. If it's detect it was dark, then it will activate the circuit and send the signal if there's a motion to the MCU. So now let me go solder this LDR and we test again. So here I already soldered the LDR at this position. Okay, if you notice, you have two places where possible to solder the LDR, either here or here. You can see these two holes. Okay, but the correct way is to solder it at this position, which is near the connectors here. Okay, this one is being meant to use for the NTC, which we will talk about it later. So the LDR need to be connected here, just directly solder. And later I'll show you, maybe I'll overlay the what they call a picture of this module with all the locations and the purpose of these extra pads. Then we will just cover it again. Okay, so now the LDR and the sensor, they are located inside. So now let's see how it's behave when there's a light and how it's behave when there is no light. I already now connecting the USB to the Arduino, so the system should be powered up from the USB. So now if you notice, whenever I make any movement here, the LED doesn't light up at all. Okay, because we have added the LDR. Now the LDR senses there is a light in the environment, so it won't send any signal, or it will disable the internal system of the sensor, so it won't send any signal. But now let's make it dark and test again. Here we go. You notice now, once I make it dark, then I just move a bit and it's triggered again. Let's repeat again. I will reset. Here we go. It's already reset now. So if I make any movement now, the LED should trigger. Here we go. You see, I move my hand, triggered again. So now if I turn on the light and reset again, the LED shouldn't work at all. Means the sensor is being bypassed or disabled because the LDR detects there is a light. So no need to send a signal to the MCU to activate the light, because it's already bright enough so the human or the person can walk through the corridor or go into the whatever place you place the sensor. But if it's dark, you see, I'll turn off the light. Once there's any movement, here we go, you see the movement, trigger the LED again. So with these guys, we have learned how to use the PIR sensor and also how to add the LDR so we can use it as a light activation system, so can save the electricity bills, especially at the daytime. So now I believe we have reached the last part of our tutorial. So if we disconnect again the cover from our PIR sensor, we will see that there is another place where we can install an NTC. You can see here these two pads, they are meant for NTC or thermistor sensor. Why we need thermistor sensor? Because this sensor is really sensitive to the extreme hot or extreme cold temperatures, especially for those places where it might be very hot or very cold. This sensor, the sensitivity of this sensor might be drift. So So that's why we can add the NTC to compensate the accuracy of the sensor. However, for me, I believe there's no need for time being, because here, even if I add the NTC, I don't have that extreme hot or extreme cold weather to demonstrate for you guys. So for now, I'll skip this part. However, if you guys manage to do this in your place where it's very hot or very cold, please do let me know in the comments. So with this, guys, I have reached to the end of this tutorial. I hope you have learned something from this, where we were talking about how to use the sensor as a security system, where trigger the alarm where there is any motion or any human being moving in the surrounding. And then we learn how to add the LDR to use it as a light detecting system, okay, where it will send a signal only if there is a motion plus it's dark to activate the light. Then also we talk about the NTC and how is the extreme hot or extreme cold affecting the accuracy of the sensor, and we will use thermostat to compensate that effect. So thanks a lot, guys, and stay tuned for the next tutorial.